figure out. So this should be broadcast live if you go to that URL. If any of you have your laptops around, it should allow you to watch this live on your, I don't know, I'm just testing this out for the first time. All right, let me get over here. Okay. So I've been doing a lot of work lately to convert our project over to Webpack, but I want to explain a little bit about the road of why we went with Webpack, how we got here, and what's going on. Just to kind of ease some of some concerns that may or may not exist about this tool in general. So one of the biggest questions is, why did we even choose Webpack? And what are the alternatives? Because that's important too. You don't want to just blindly go with something, right? I wrote a blog post sometime around the summer of last year explaining, or at least evaluating a number of different build tools for front-end assets, but I had missed Webpack. I didn't even know about it at the time. In that blog post, I talk a little bit about Make. So it had come up on a couple forums that Make was a viable option for building front-end assets. It's not, you don't only use it for building, C++, C applications. You can use it for just about anything. And there was a lot of benefits to that. I mean, it's been around for over 20 years. It's not bound to any specific technology. You can use bash scripting. You can use any CLI tool at your discretion. And you got ordering of your build tasks in Make. But you're also limited on what you can do there. Right? Everything you have to do is through CLI tools, pretty much. So you don't really have a lot of flexibility with what you can do. And most of what you would have to do is, through those CLI tools, is generate a lot of temp files in the process. So you're touching your disk a lot in your build process. So didn't really think that Make was going to be the right option. Looked at Grunt. Grunt is a very configuration over code methodology. So if you ever look at a Grunt config file, it's a lot of just JavaScript objects, not really even any functions, or it's really kind of odd trying to get anything done in there. You can do it, and as long as you're adhering to a lot of default conventions, it's great, right? But it doesn't give you a lot of flexibility. It has a great plugin ecosystem. There's a lot of plugins for Less, for just about any require, browserify. It can tie a lot of different things together, but in all reality, it was all that configuration over code that made things a little difficult. What did Joe say? I'm not recording, huh? I will do that right now. I thought I did. So it says broadcast. It says it's live. So. Okay, it does. Yeah. It does say it's live. So sorry, Joe. I don't know what's going on there. I do see that you're not in the room, but it should be on YouTube later.
Are you using Google Hangouts?
Yeah. I don't know what's going on there, but it is broadcasting live. So at least that's what it's telling me. So so because of all that configuration of the code, honestly, a lot of the community support for Grunt is actually starting to migrate away from it. It was a really big tool for a long time, but it's starting to kind of shift. Looked at Mimosa. We even used it internally on our One Exchange project. Mimosa also kind of followed the concept of Grunt, where you have more convention over code, but it was easier to get in there and write code to do things, right? It also had an advantage over Grunt, where a lot of the file manipulation was done in memory. So you start from your source files and come out with temp files. Grunt actually does a lot of temp files in the process as well. There's ways you can do Grunt that won't, but found that a lot of the plugins resulted to temp files. But in the end, Mimosa just kind of did a little bit too much. It tried to do all the scaffolding, the building, asset management. It was just a little bit too much and never really got a lot of community adoption. Found Gulp, which is just basically just a little bit better version of Grunt. It dropped off most of the configuration files and went through more of a code-based way of doing things. And it introduced the concept of streams, where you start from your source file and stream everything through to your output file. It performed much better than Mimosa and Grunt. So there was that going for it. A lot of community adoption is really growing for Gulp. So we had originally, so let me go back real quick. So this is the file I/O concern. At the time, we were looking at using a lot of CoffeeScript files, and we needed to transpile those to an output file. And when we were using Grunt or Make, what was happening is we're getting that intermediary temp file, which actually made the build process slow and not very efficient. Whereas Mimosa and Gulp, and as we'll see later with Webpack, starts the input and only comes out with the output, so you don't touch disk in between. I'll actually highlight at the end, there is a capability of Webpack to even bypass in development that final write to disk. Don't even need to do that. So I'll get to that towards the end. There was another one that I'd heard of. I honestly only spent maybe 30 minutes looking at it, broadly. Honestly, it seemed like a much more complicated version of Gulp. It does advocate analyzing your dependency tree, but that was really all the main selling points it had. It just seemed real. There was a lot of mental overhead to figure out even how to work the thing. So I didn't spend a whole lot of time on it. So we decided to go with Gulp, and we were going with that for a little while. I think we were about a month in working with Gulp when we stumbled on this YouTube video from Pete Hunt at OzCon last year up in, I think it was either Portland or Washington or Seattle, one of the two, I don't know exactly. And he highlighted a lot of different concerns, and he even touched on all these tools and why they didn't go with any of them. So, and why he went with Webpack. So to touch up a little bit about what he was getting at with this, he kind of went back and looked at the history of web design. All right. So I'll explain these pillars in a second. So early days of web design, we did server rendering. Everything was done on the server. Right. We spit out an HTML file. If you want to do anything, you do a post to the server, and you do a full page reload. Right. So it was relatively fast, but not great. It was really easy to implement dev-wise, so the green, right, really, really easy. But the user experience really sucked, because depending on where you were and what your internet connection was, that full page reload could be really expensive for the end users, right? Really dependent on what was going on with their network. So then we started moving towards server-side rendering with AJAX calls to do small manipulations of the page, which is honestly what we mostly do for a lot of our apps here today. The server is actually able to do that a little quicker, so good there. A little bit more dev effort because it requires us to figure out how to write JavaScript and do AJAX calls and update the page with that, with those updates. And the user experience got a little better, right? Because they're not getting those full page reloads all the time. And now we get into the single page app of today's world, right? A little more difficult to figure out how to do that on the server, right? So the server has to do a little more work. Dev effort's a little bit more difficult to do, but the user experience is amazing, right? Because they're not constantly seeing these full page reloads all over the place. They're just, it's almost seamless, right? And so you get the single page applications. So when I'm talking about load performance here, it's not just the server, it's also the bringing down the assets to the client. So when the client gets it, what does the client have to do to bootstrap your application? Because now you're moving bootstrapping down to the client, right? So it's the full server and client interaction that needs to go before anything's shown to the user. So the question is, how do we make that better, right? So the best way to make a single page app great is to limit our number of HTTP requests, for mobile, that is especially important with mobile, and limit how many bytes we're actually requiring our end clients to download, right? We don't want to make them download everything and their mom's birth certificate, right? They don't need to get all that information just to show our app on their first page hit. So we figured out how to get things a little bit better. We start concatenating our JavaScript into one file. These numbers are taken from Pete Hunt's presentation that he did on Instagram and where they were at when they were first starting. They had a 9.5 megabyte minified JS file and then gzipped it to 2.5 megs. Now, 2.5 meg is still a little big for a client-side download, right? Requiring them to download that. But not only that, you're requiring the user's browser to parse and run 9.5 megs of JavaScript before it can do anything, right? So it's not very efficient. And depending on how much CPU their computer has will really dictate how fast they can parse that and get it going, right? It's not a great mobile experience because mobile devices have much fewer resources than a desktop computer. So this really helps with desktop applications, but not so much mobile. So the right way to do JavaScript or do single page apps is to only download the JavaScript you need for each page, right? Well, it's a single page app, so why is there a page? Well, as they move throughout the app, they should conceptually move through different pages, right? It helps us understand it, and it helps the user also understand it. But the main point is if you have a URL that the user can land on, that's a page. So if you do some kind of client-side routing, you're using the HTML5 history API, the user doesn't even know that they're doing client-side routing a lot of the time, right? So that's technically a page as far as the end user is concerned. So yeah, so the single page app, a page is an entry point or somewhere where you can actually hit the page for the first time. And subsequent navigations on that page should not download and reparse and refigure out all that JavaScript again. They should already have it because they've already landed there before, right? So if you go on the login page, you log in and then log back out and go back to the login page, you should have already had the JavaScript. You don't need to download it again. But there's other static resources as well. With single page apps, we need to style them, we need to make them look good. You need to give images, fonts, whatever else you need to have available for the client to use. So why not also include those in the dependency graph? Right? They're needed for the page, so why not include them? And while we're at it, let's just treat them as modules as we're used to using in JavaScript. Why not? That way we can use the same tools that we're using to do all of our module management with JavaScript. We can use those same tools for our other assets as well. A word of caution on this, though, it does bring some interesting aspects to deal with your CSS, right? Because you can technically land on any entry point, which means any or all of your CSS might be present on the page at a given time. It can be loaded in any order, which introduces problems of specificity, making sure your class rules can happen in any order. It gets interesting real quick. And finding dead and finding dead code or dead rules in your CSS is actually very difficult to do because now it's being loaded in any order. How do you know if it's being applied or not? All right, so that adds a lot of overhead to figure out. That link that was on here earlier, and I'll post these slides up, that shows Pete Hunt's presentation. He does a little bit better job going in and explaining a lot of the CSS problems with this approach. I'd recommend everyone to go watch that. It's a very detailed explanation of the CSS concerns to deal with in a single page app. P-Hunt also went through and built up a nice, really good Webpack how-to README and an example app. You can go check it out there, and I'll actually show it here towards the end. And I'll come back to that in just a second. All right. Any questions so far about Webpack and what it's trying to accomplish? No? All right. So let's go ahead and get into a little, I have my speaker notes over here, but now I can't see over there, so I'll get a position. All right. So I'm going to take an example from Kent Dodds. He put together a really very simple web application to show how to migrate to Webpack. We'll go ahead and do that as an exercise together today. Kent Dodds actually lives and works here in Utah as well. So if any of you run into him, he does go to the React.js user group meetups here, so you can run into him. So it's a very simple HTML page. We're just going to stick with all static. We're not going to do any server-side stuff at all. But we got two style sheets, some buttons, an image, and a small little form, and then 4 JavaScript files, right? So of course, it brings up on the other monitor. All right, so here's this little app. Really small, pretty simple. We got some buttons, just pop a little alert, and a very horrible, but at least trying to show JavaScript is doing something on the page, doing some binding of data, right? So let's see if we can at least collapse, first off, these 4 JavaScript files down into one file. We'll go ahead and do that first. So we're going to add a webpack.config. Now, if you're used to CommonJS, a webpack config is just a normal CommonJS module that just returns a JavaScript object, and that's how you configure it. The minimal things necessary that you need to give Webpack is an entry point. In our case, it's the index.js file, and you have to give it an output. And where to write that output to. That's all that you need in order to make it work. All right. Once that's done, you can just run Webpack from the command line. Bam, you got yourself a new file right here. So if we refresh this, we've now got a bundle.js file. You'll see if you look at these bundle files, you'll see that there's a little bit of Webpack boilerplate. If you're used to working with require.js, this is similar to Almond, which is when with require.js we try to optimize and get everything to one JavaScript file. Almond is that little bit of boilerplate to wire things up in a non-asynchronous manner. And then right here we'll actually see the module. So if we look over here, here's our index.js. It's normal conventions of a self-invoking function, and you can see it in the output right there. I just pretty much just took exactly what was there and threw it in. Webpack will wrap it in a function for us, so we don't even need to do that. So let's go ahead and clean that up. I'm going to go ahead and throw on a watch mode with Webpack so that it'll just keep updating that bundle for us. But at least we can see that, yeah, it is updating it. right? We don't have that. We don't have a double self-invoking function going on anymore. All right. But now we have some undefined variables, right? If we tried to load this, well, let's real quick change our index.js now, or sorry, index.html. Let's not be downloading all these different JavaScript files and just stick with our bundle. Right? Now, we tried to load this. We got our CSS coming in, but our alert button doesn't work, and the DOM bindings don't work either. All right? That's because of these modules that are no longer defined. They're no longer being put on the global scope. So using CommonJS, let's go ahead and bring those in. Our linter's happy now. And now if you look at that, stop it right here from Webpack, you'll see now it's picking up more JavaScript files. All right. But if we tried to load it, it still wouldn't work. We still don't have our alert button working. And we still don't have the bindings. And the reason for that is that now we need to also go through and update these guys to be CommonJS modules as well. Webpack is pretty awesome. You could also do this in AMD, but let's use CommonJS because it's the more modern way of doing it. All right. So got our alert buttons and our lame DOM binding. Thank you. Okay. Figure that out with the ESLint. I just barely started playing with it, and if you do multiple file writes, I get multiple location lists. I'll have to figure that one out. All right. So Webpack noticed when I noticed the different file changes and kept outputting that bundle.js file. And now if we refresh, our alert button, come on. Nope, still not working. Okay. So what's going on with that guy? Oh, he's got underscore dependency. So let's bring that guy in. Or not underscore, Lodash. All right. All right, so it's working. And the DOM bindings are working as well. All right. Any questions on what happened there so far? You see there's our main index.js, and now the alert and lame DOM bindings are all in that same JavaScript file. All right. So a very simple web app, not a whole lot necessary. We don't nearly need to split it up into multiple JavaScript files because this is really small. All right. So not a whole lot of complication with Webpack here. Just a few lines of configuration, change to CommonJS, and we're done. But let's see if we can go ahead and take this just a little bit further. We also are incurring multiple network requests for the style sheets coming in. That's not necessary. And if we were to migrate this to be a single page app, how do we ensure that we have the CSS that we need for the different JavaScript models that we have active at a given time? So let's go ahead and remove those. And I'm going to go ahead and move this guy up into the head. This will be blocking while we download the JavaScript, but it'll ensure that our styles are working once the JavaScript is loaded. All right. There are some things in Webpack you can do to extract the CSS out into CSS files again, so that you can split them back up. But I haven't really fleshed that out yet and understand how it works. So I'm not going to talk about it too much more than that for right now. So now, all you need to do is in your index.js, just bring in your index CSS. And it was bringing in Bootstrap before, so let's bring in Bootstrap. So Bootstrap is actually in our node modules, and luckily Webpack knows about node modules, so you just need to reference the module by name. Let me remember the full path here. So Bootstrap, dist, CSS, there we go. All right. Well, that's not quite too interesting and actually won't even work quite yet. Webpack is actually blowing up because it doesn't know what to do with CSS files. All right. So we need to teach Webpack about CSS. All right. So I'll explain this in 1 second. I need to restart Webpack to pick up that config change. Come on. Unexpected. Oh, where are you at? Let's jump to the end. All right, so if I refresh this guy, I don't know what I did wrong right off the bat. Oh, in his example, he went to less right away. So look at what he's got going on. Okay. Looks like he's still bringing in Bootstrap on its own. But if you'll notice in here, he is bringing in his index. He converted it to less. He's also bringing in a different CSS preprocessor called style. So he's mixing both less and style together to show you can do that with Webpack. And you can see index less is now it's doing some alignments and whatnot. He added a new dependency. Oh, come on. Okay. I was hoping to get to that part in this project, but I didn't flesh it out enough beforehand. Apologize for that. Main thing here is with Webpack, you have multiple loaders and you match files based off of a Redis pattern, and then you can go through multiple loaders. And the way Webpack works is it works on the loaders from right to left. So if you give it, for example, with less here, it would start with the less loader, which goes through the less transpiling step. Go to the CSS loader, which inlines the CSS into JavaScript, and the style loader puts the little bit of JavaScript magic necessary that you need into the JavaScript to actually append that CSS to the DOM when you run the script. So all you gotta do is call require your less file, and it'll be applied to your page in the end. All right. Any questions about all that offhand? He's also going through a couple other steps here. He's changing his JavaScript to use ES6 with Babel. Babel's a ECMA6 preprocessor to make it ECMA5 compliant. So, any questions? Anybody? All right. So this is Pete Hunt's example that he had. And he's also going through and doing a bunch of the, if you look at his Webpack config, not much different there. They're all fairly similar. He's using a different loader for his JavaScript, so you can use whatever you want, really. But he's also using Less. He's being more explicit about the loader names. By Webpack convention, you don't need to do the dash loader. Webpack will just put that on there for you. So you can use whichever style you like. And with his, with that bundle.js, and then there's 201 modules involved in this guy. A lot there. So let's see what it looks like. Well, that looks awesome. Okay, I should have run that one a little better too. Well, we'll come to this one. So I've been playing with this a little bit personally too, and this is a much bigger example. This is, I'm rewriting my blog to be on Node.js with React, ES6, Less, and fully isomorphic where it renders on the server and on the client. So there's a whole lot going on in here, but in a slightly more complicated Webpack config. But I have one JavaScript entry point, which is in my lib folder, my client. It's actually going to output to my public folder, and it's going to prefix all the URLs with public, so that when Webpack tries to get more assets, it knows where to find them. And then it's going to do some chunking for me. So I'm not just going to land with one bundle.js when it's done. I'm actually going to have a lot of JavaScript files, but they're going to be smaller. So if you look at this public folder, I got my main.js, and then crazy numbers that don't really mean a whole lot to me right now, some images that are mingled, and some common.js. So what has made that possible is Webpack has a concept called require ensure. So what I'm able to do, for all my post entries, I have a template that I create that will dynamically chunk out all my posts into independent JavaScript files. I don't even need to think about it, it's just chunking it all out. I can do some configuration in Webpack to say, hey, the chunks need to be at least a certain size, so it might actually take some of those and slurp them together. But Webpack's managing all that, I don't even need to think about it. All I need to know is how to dynamically bring in this other module. So, in the end, I have a blog post or a blog engine that rendered my HTML on the server, appended all the script tags I needed to get my common.js and my main.js, So the Webpack split things out to have all my pages are going to use stuff from Commons. So let's bring all that out, and it'll be brought in on every page. The main is just the minimal that I need for routing, and then and my home page. And then if I come to one of the posts, for example, if I refresh, I see there's a slightly different order to the JavaScript here. I had an arbitrary chunk of JavaScript come in, which is my actual blog post entry as JavaScript, and then my main, which applies the routing layer. But you'll notice that the CSS itself did not come through. There's no CSS files, but I have styling. So all the CSS was bundled into my JavaScript. It's in there somewhere. I don't know exactly where. Find this guy. This guy's a little bigger. Still working out some of the kinks with getting the right stuff in the right location. That's too big for Chrome to open right now, at least in a decent way. Yeah, there we go. So somewhere in here, there's going to be some CSS. So there's all my CSS. It's there inlined into the JavaScript. So
what does that look like if you want to inspect an element with its styling? And then, so like if you wanted to look at that masthead H1, and you click on the link next to it that shows you where it's at, what does that show?
this guy right here.
Yeah.
I'm working on a pull request right now to fix some of the source map issues, because there's still some source map problems with the CSS. It's supposed to be better if you're doing the extract the CSS to actual CSS files, but I haven't figured that out yet. But you can at least see what it would look like. You just got to find the right file now. Because this right here is the actual fully compiled less file. I don't have the less source maps applying here yet. So that line number wouldn't match up to the actual index less file right away. But I should have that figured out here in the next week or two. Any other questions about all that? It's a lot to consume, I know.
How did you configure how it gets done?
So I'm going to show. I've got all of my Markdown. So I write my blog posts in Markdown. I wrote a custom parser that takes that Markdown and converts it to a React component. And then there is a Webpack module or loader out there that you can get that does a proxy loading of a React component that will do that chunk split point for you. But I wanted to have that chunk split point have some metadata about the blog post without actually having full content for the blog post. So I have my own custom version of it. That was the file I showed earlier, which had the required sure in it. So with Webpack, the way the loaders work, remember I told you they go from right to left. Webpack also has a second concept of actually dealing with the loaders from left to right using a pitch. And if it hits a pitch, it actually stops the tree and doesn't do anything on the right to left, which gives you a chance to enter or create your split point. And then you can, after that split point, Webpack will finish the rest of the chain from right to left up to that pitch and keep them as two separate things. So that's where I've got that split point happening right there, is in this configuration. If I was using entirely the proxy loader that Webpack has up on GitHub, it just would have been a loader. I could have done it as a string, React-proxy, bang, Babel, So basically, in this case, so when you're defining your loaders, you can do them either as an array or as a string with a exclamation point separating them. And it was a little easier to read in this case to put it in an array.
Does it read arrays first to last?
Same concept. It reads them last to first, unless it's doing the PIS. The PIS goes from first to last. I'll go ahead and post all this up to GitHub so you guys can dig through this code base. Still working on getting some of the code base to be fully ES6. It's not entirely yet. For those of you who have seen that or are aware of what that looks like. So there's a few differences. For example, I don't need to do render colon function. Just do render. Sometimes that's a function right there in object. So it kind of cleans things up a lot with ES6. Few things to clean up. This is React outside the scope of Webpack right now, but so there was one more thing I wanted to show, which this is probably the ugliest web page you've ever seen, but I want to kind of drive something home at least. I mentioned earlier that that with Webpack you don't even need to touch your disk in development mode with your changes, right? So, and the way you can do that is with another command line tool called Webpack Dev Server, which will do everything that Webpack does except write everything out to disk. It will stand up a server for you that you can then go hit. So I just finished building everything for this particular website. It's up on 4080p. And Webpack is actually standing up a web server that shows you all these files. So if I wanted to go look at the bundle that it creates for me, I believe it's this guy. Nope, it's not that guy. Can't remember exactly which one it is right now. Actually, I don't even think it's there. What's interesting, even more so about this, is so there it is. It's going to be at index.js. So there's the file that Webpack built for me. But if I try to go look in my directory over here, it's not that. And there's no other files that it would be. So Webpack is maintaining that file in memory, and it's watching my changes. So if I went and I made a change to this index.js file, it would make that change to that bundle script file in memory, never touch disk, but still serve it. So you can develop a little quicker. Webpack will take that just even a step further. Notice I have no HTML files in here. But if you give it an entry point, Webpack will be kind enough to generate an index HTML for you. All right. So this is a dummy app I spun up real quick just to test source maps. So if we look at this guy over here, we still trying to work out some kinks with this, but is it just off the page there? No, never mind. Not working right now. Yeah, so the source maps aren't working right now with this fork I've got going on right now. But the main point here, though, is there's really not, we got our index, that's the file served up by the Webpack Dev Server. And then my CSS is getting base64 encoded and inlined in there. Yeah. I mentioned earlier that Webpack will manage all of your assets, not just your JavaScript and CSS, so it'll manage your fonts and your images as well. So one of the things you can do with images, as an example, is if you have a really small loading wheel, for example, there's no need necessarily to make the user download another file for it. You can actually take that image, base64, code it, inline into your JavaScript, and one less network hop for something tiny. So those wonderful 2 pixel by 2 pixel backgrounds that we repeat no longer are an individual file for, like, what, 4 bytes? Instead, you can inline that directly into your JavaScript and CSS. And Webpack will do that for you. And you can put whatever threshold you want. So you can say any image that's under 5K, let's go ahead and encode that. Otherwise, force a network hop to go get that image. So a couple of the things there with the Webpack. I highlighted the Webpack Dev Server, but there's also another module out there called the Webpack Dev Middleware. So if you're writing a Node.js server, you can actually inject the middleware directly into your Node.js server that you're running in development. So you don't need to host 2 separate processes. Since we have a C# server, we would definitely need to work with this Webpack Dev Server and proxy. There's proxying capability here that I haven't highlighted that would allow you to proxy to your actual server that's serving database connections and whatnot. So that's all I've got right now on Webpack. Any questions? Go ahead.
Are there any cache busting solutions that?
Yes. I didn't really get into it right now, but what you can do, and I haven't implemented this yet in my blog, I will soon, is up here where you are specifying your file name. You can actually also put in here a hash. A Webpack will take an MD5 checksum of the contents of that file and put it into the file name, right? You can also do that same thing with these chunks down here. They can also have that dash hash. So now it's never the same file name unless the content hasn't changed. That's actually really important. So these images right here, that's an MD5 hash checksum of the content of that image. So as long as you don't change that image, you shouldn't be breaking the cache or busting the cache on a deployment. It would stay the same.
How do you reference the file? It's going to have a hash in it. How do you reference it since that hash may change every time?
So I wrote a plugin to Webpack that does that, which I reference right here. And what this does is it generates a JSON file for you that is a map of original file name to new garbled file name. So that regardless of what server you're using, you can figure out what that actual file is.
On your HTML, how do you reference your JavaScript with the hash?
You would have to do the same thing in your server templating. You need to get a file name based off of that JSON file lookup. If you aren't doing the hashing, then you can just the file name set. You can just grab that. So there's a couple things. There's a couple other strategies that have been done here too. One of the strategies we've looked at is for JavaScript files to use the version number of the application, since usually at runtime of the server, you know what the version is, so you can predict it. You wouldn't need that file now. But for the images, you would need that because you don't want to do version number on images. So the MD5 hash is better there.
Purpose of the hash. I have a question on
For cache busting. So you can leverage the use of the browser to cache images, fonts, JavaScript files for you, so that you don't have to force the user to re-download them. So if the user hits F5, they should load their page faster than the first time they hit it, right? Because they've already downloaded those files. Why make them download it again, right? But if you change your app, you want to force them to download new stuff, and that's where the cache busting comes in. Right. Anything else? All right. Thanks, guys.